Hello again, this is Brad Johnson with Lavender Camps, and today I'll be talking about the different types of sensors you can use with your LEGO Mindstorms EV3 robotic system. First, I figured we could start with the most fundamental sensor of all, the actual buttons on the EV3 brick. Now, first, let's look at the EV3 button press block. So, as we can see, we can either measure an individual brick button that's being pressed, so the state of the brick button, or we can compare a change in brick buttons. And Jack went over the different brick buttons on the EV3 brick in his video about the EV3 hardware. So let's look at a weight function. So let's switch to brick buttons and let's look at the compare. First, we can compare a button's state. So we can even look at a set of buttons. So we could have multiple buttons as the input into the weight block, as well as whatever their state is. So if their state matches either released, pressed, or bumped, much like the touch sensor, then the weight block will trigger. And right here, this will output a set of buttons, which would be the input here. So 2, as we can see, is the center button, 1 is the left, 3 is the right, 4 is the up, and 5 is the down. So there's no, and then nothing at all. So that would be 6 different sets of buttons, and we can click multiple buttons in here. Also, we have the change. So the change would just wait for any button press to be pressed. So any of the 5 buttons, if they were pushed, released, or bumped, it would trigger a change. So this is the EV3 touch sensor, and the cable goes in the back. The touch sensor has one purpose, and it's to be touched. So it acts as a giant button. I can press it down, I can release it, or I can bump it. Now let's look at the software side of the touch sensor. So first, let's look at our touch sensor block. As we can see, here's the port. So the port can be indicated here, or we can have a number input for the port. And the touch sensor can output either its state, which we'll look at in a minute, or it can do, again, a comparison, a change of state. So if whatever the measured value is not equal, or its comparison, illogical, so it would either be true or false. So this is the state output, the measured output, and this is going to be the compared result. So this is a logical output, and that's going to be a button press number. So let's look at our weight block again. As we can see, we go to button sensor, or put touch sensor. Here it is. And we have, again, compare or the change. So this would be any change in state, and this would be the output for the state. As well as we can do a comparison of state here. So there we have it, and we can check it with the is this button pressed, released, or not. Another useful thing would be in the use of a for loop. As you can see, if we change our for loops options to include a touch sensor, the for loop will continue until the button, in this case, would be pressed or bumped. So this for loop will continue to loop, and then it will exit when the button reaches state 2, which is bumped. Now, what would we use a the touch sensor for? One, it can be used as a button. Additionally, if you have some form of moving robot, you can use it to do collision detection. So if it hits a wall, it can respond accordingly, or to know whether or not an object has been picked up by a claw or something of the sort. This is the EV3 color sensor. It's capable of detecting different color wavelengths as well as detecting a difference in color between 2 points, as well as detecting the intensity of the ambient light. From a software point of view, the light sensor, or color sensor in this case, has it's a more versatile sensor than a simple button press. So let's look at the color sensor's block. So the first thing we notice is it can do a measure. It can either measure a specific color that it can output, the reflected light intensity, which would indicate that it has a little light next to its sensor and it will turn the lamp on, and it can measure a reflection. Also, it can just look for an ambient light intensity, so it could tell relatively how dark our light of room is. And let's say if someone turns on the light switch in the room, they could respond accordingly. Additionally, it can do a comparison between colors. So we can specify a couple different colors here, and it can do a comparison and output a logical result, as well as the color that's red, whether it matches the logical result or not. And as you can see here, we have a set of colors, so we can check all these colors. So we can even say respond in any situation except brown. We don't like brown, and you can do that. So you can do this with compare with light intensity as well, so reflected light intensity. And honestly, with the reflected light and the ambient light, you're just going to have to play around with it a bit. That stuff, it's on a case-by-case basis because you don't know what the environmental factors will be if you're going to try and do a comparison here. And you can do a calibration, but we probably don't want to get into that. So looking at the weight block, you can have access to all of these options with the color sensor. So you can do, again, change in the compare functions. And the uses of a color sensor would be detecting the specific color of something you might be picking up. So if there's a ball or a brick or what have you, it would be able to detect and respond accordingly based on a specific color. Additionally, you can use the intensity or the color sensor to follow a line or respond to a line. So you could make a virtual pen for your robot by drawing a black line around it. So those are the two main functions of the lighter color sensor. Another interesting function would be to cover the light sensor and not have the robot start a program until the light sensor is revealed. It can be used as like a start button in the event both touch sensors are being used. This is the EV3 Ultrasonic Sensor. It's capable of detecting things up to 100 centimeters away from in front of the eyes. Alright, so now let's look at the ultrasonic sensors software capabilities. So if we go to the ultrasonic sensor and look at its default port is 4, and what it can do is it can measure a distance. This looks like a raw value, but let's see. Measuring mode 0. Interesting. Okay, but for the basic things, you can have a distance in centimeters being output, and you can have a inches, and you can just look for a presence So anything that pings it. So if there's another robot sitting and not moving, the ultrasonic sensor will detect it if the other robot has one. Additionally, you can do comparisons, so you can do a threshold value, you can compare any of these compare functions against the actual distance being read by the ultrasonic sensor. Now, a couple of uses for the ultrasonic sensor include distance, so you can look for walls and detect walls, or you can detect other objects. So you can have it spin around until it detects an object a certain distance away and then move towards it. So if you're detecting another robot or something like that. Additionally, the EV3 software has some cool stuff with the range function. So you can use the range function along with logic such as the switch case function, and with these two things you can program more complicated responses, or like have the robot behave differently based on how far or close in chunks, like 150 to 100, 30 to 25, specific chunks of distance, and you can have a different response for each of those ranges, and that makes it's really versatile because of that. So this is the EV3's gyro sensor, and it's capable of detecting rotation this direction or this direction. So the last primary sensor that I'm going to be going over is the gyro sensor. And so the gyro sensor, we can see, has an output, and it can output in an angle, so that would be some degree measurement, much like an angle you can use to power a motor. For example, just for the fun of it, I can read the output from the gyro sensor and force the motor in degrees to make that rotation. So that's an interesting little idea. Additionally, so you can measure an angle, you can also measure a rate. So this is degrees per second. It's going to be a rate of change. So the faster you move, the faster you rotate, the faster it will respond. So you could use it as kind of like a jerk sensor and use that to determine the power or response or something like that. So that will output a number. And also you can, again, output both the angle it's currently at as well as its current rate, and those two can work together in some ways. Additionally, you can do a comparison, so as long as it's within whatever the threshold value is, so you can have it greater than 90, less than 90, etc. It'll have its logical outputs, and it'll also have its degrees measure output as well. And this will carry over to the weight functions as well. Last, we have the reset, and what the reset does is it zeroes out the gyro sensor. So let's say you want to just record a raw degree difference between values. The easiest way to do that is to have it turn, then reset it, and then have it turn again, and you'll just have that straight number, the distance of the turn. So that's a case where you'd have to reset the gyro sensor. Also, in any case you'd really be using it in a program, you'd want to restart it at the start, or reset it at the start of the program, so you always know it's starting with it zeroed. Or if it's a moving thing, but if it's something in your hand or etc., by the case-by-case basis. This is the NXT sound sensor. It functions similar to a touch. You could use it similarly to a touch sensor, but it detects how loud a sound is being made, so sound intensity. Now let's look at the NXT sound sensor block. So the NXT sound sensor block will record values in decibels, and this is a percentage actually. So it's going to output. This will output a number from 0 to 100 as a percentage. Now there's two different measures it can do. It can be a simple decibel measure from 0 to 100, or it can do a dBA measurement. Now the only difference with the two different settings is the dBA measurement will measure with an approximation to the human ear. So it's kind of like the absolute decibels. So it'll compare those, where the normal decibel can be calibrated, so you can set the minimum and the maximum, and you can also reset it. So that can be used in something a bit more advanced potentially. So in general, dBA works best, but again, case by case basis. So you can output the measurement, which again is a number from 0 to 100, as well as you can do your standard compare function. So you can output the Boolean value, you have your threshold, and you have your comparison type. And this applies again for the weight sensor. You can wait for a certain intensity of a sound. So you can wait for an intensity of a sound to be over so many decibels, and then you can respond, or respond accordingly. And again, because there's a variation from 0 to 100 for these, then you can do a multitude of different switch case events in order to target in a specific value in order to respond accordingly to that value. Now there is one more sensor, and that's called the infrared sensor. The infrared sensor, for all intents and purposes, can act as a proximity sensor. So it will behave very similarly to the IR sensor, and here it will record proximity, and this is going to be a distance. It does have a couple other functions, and that is both the beacon and the remote function. And the beacon and the remote function will either send or receive infrared signals, and these can be used to provide a very complicated response. So there's different channels that it can send the infrared sensor or signals on or receive them on, and it can respond accordingly. And it's fairly complicated, and I won't be getting into it in this video, but just know it's available, and the kids may want to use the IR sensor as a proximity sensor. Lastly, I think it's worth our time to look at the timer. Now, the timer sensor, or it's not a sensor, but the timer is fairly important if you're doing anything with time sensitivity. So if you want to perform a certain action or wait with regular time, then this is going to be what you use. As you can see, the EV3 has 8 different timers, and for any program use, at the start of the program, all timers reset and start at 0 and begin counting upwards. And as you can see, you can count the elapsed time since the last reset. So if I wanted to perform a function here, a move here, you can read the time, and it will move for however, with power, with respect to, there we go, time, or something stupid like that. Then after it performs the move function, we can actually plug in here and tell the timer to reset. So now reset timer 1 after it does it, so the timer will begin once more from this point onward at 0. Now, other things you can look at is a comparison. So you can do your elapsed time comparison right here, and that will output the Boolean event, the result. And you have a time here. This is your threshold with a time, and your comparison function here. And you can also choose your timer. And once more, it'll output the timer here. Now, as far as the wait block goes, the wait block can use timers, so you can do compare or change in a timer. So elapsed time of 5. But if you're doing something with time sensitivity, it's usually just easiest to change and go down to time here rather than use the timer with a change, because you can just specify the number of seconds here. So I can say this will be 5 seconds here, and that's basically it for as far as sensors go and for timer usage. Hope you learned a little bit today, and I'll see you in the next video. Take care.